Okay, we come to the next problem. Consider three processes with process IDs 0, 1 and 2 respectively with compute time bursts 2, 4 and 8 time units. Okay, so these are the time bursts of these processes. All processes arrive at time 0. Okay, so all processes arrive at time 0 and consider the longest remaining time first. Okay, so this time the longest process gets into the CPU first. Okay, longest remaining time scheduling algorithm. In LRTF, ties are broken by giving priority to the process with the lowest process ID. So if you have two processes that have the same amount of remaining time and that is the longest remaining time, then you have a tie, and to break the tie, what you do, you give the priority to the process with the lowest process ID, because you have these 0, 1 and 2 process IDs, and then you have to find the average turnaround time. Okay, so there are a couple of things out here. uh, the first one is longest remaining time, which is clear because as the processes will run on CPU, the remaining time will decrease, and the one with the longest remaining time will get the priority. Okay, so that's one thing. And the other thing is about average turnaround time. Okay, so what is average turnaround time? Average turnaround time is the time, total time. Okay, is the total time that a process takes. Total times mean the time at which the process arrives and the time at which the process completes. So the difference of these two times. Okay, the time at which process completes minus the time at which process arrives, that's the turnaround time. Okay, that's the turnaround time for that process, and if you take the average of turnaround times for all the processes, you get the average turnaround time. Okay, so let's see what we can do out here. So uh, okay, so all these processes arrive at time 0. So if this is 0, then this is a good thing that all of them will arrive at this time 0. Okay, and for these processes, I'm writing them P0, P1 and P2. Okay, their IDs are 0, 1 and 2, so I write them P0, P1 and P2 like that. Okay, so what is the burst, the CPU burst they need? Okay, the time they need in CPU. P0 needs 2 time units, P1 needs 4 time units, and P2 needs 8 time units. Okay, so that's what I know, and I'm writing this down because these will change, and accordingly the process will get priority out here. So the first thing, what will happen first? Okay, the first thing that will happen is all of these arrive at time 0. So at right now, which process has the longest remaining time? That is process P2. Okay, so P2 will be given the CPU. The CPU will be given to P2, and P2 will run on CPU, and as the time will pass, this remaining time for P2 will decrease. Okay, so it will decrease from 8 to, let's say, 4. Okay, and this will happen after 4 time units. So that means that when you are somewhere out here, let's say at 4, okay, that the remaining time of P2 becomes 4 and the remaining time of P1 is also 4. So at this time P1 will get priority. Why? Because there is a tie. For both of P2 and P1, the remaining time is 4, and in that case the process with the lowest process ID gets the priority. So that means that P2 will be kicked out and P1 will come in. So P1 comes here. Okay, and then what happens? P1 runs. Okay, so P1 runs, let's say, for 1 time unit. Okay, yeah, because it will cover 1 time units. That's the assumption you have to make, that a process has to make at least 1 time unit before it is kicked out. So at this time, what happens is the remaining time is 3 after 1. Okay, so then what happens at this 5? Now P2 becomes the process with the longest remaining time, so P2 comes in again. Okay, and then P2 runs for 1 time unit, and then it also becomes 3. Okay, then the same thing. Okay, P2 is kicked out, and this happens at 6, and then again there is a tie. So which process gets the priority? But the one with the lower ID, that is P1. So P1 comes in, and then you have the same thing again. The P1, it spends 1 unit time, so 2 time units are left, and then again P2 becomes the one with the longest remaining time. So what happens is that after this 1 time unit at 7, it's again P2, so P2 comes again, okay, and the same thing repeats. So then what happens, this P2 is gone, the time goes up till 2, okay. So when this happens, then what do you have? So P2 is up till here, okay. So this is what happened up till here, okay. P2, P1, P2, P1 and P2. So at this point what you see is that all the three processes have the same amount of remaining time, which is equal to 2, and then there is a tie among all the three. So to break the tie, you give priority to the process with the lowest ID, and which in this case is P0. That means right now P0 will come in, okay, and when you will run P0, it will be decreased to 1, and then there will be a tie between P1 and P2. So you can see what will go on, okay. So there will be P0, there will be P0, and then there will be, after 1 time units, there will be a change, P1 and P2. When this is done, all the times will be decreased by 1, and you will again have a tie, and then again you will repeat the same thing, P0, P1 and P2. So this is what is going to happen, okay, after 1 time unit for all of these processes. This is what is going to happen, and then finally at this point everything will be done and all these will become 0, okay, and these will be 1 1. All this will be 9, this will be 10, this will be 11, this will be 12, this will be 13, and this will be 14. So then what you have to answer is average turnaround time, okay, average turnaround time. So that means you have to take average of all the turnaround times. And what did we know about the turnaround time? It's the time difference between the time when process completes and the time when it arrives. So all the processes arrive at time 0, and let's look at their completion times. P0 completes at 12, so the turnaround time for P0 is 12 minus 0, that is 12, and P1 completes at 13, so the turnaround time for P1 is 13 minus 0, 13, and the turnaround time for P2 is 14 minus 0, 14. And when you divide this by 3, you get the average turnaround time. So this will be 12 plus 13 is 25, plus 14 is 39, and 39 divided by 3 is 13, which means the option A is the correct option.